Welcome to this getting started video with JavaScript. Today we will be working with a semantic analyzer, a type checker, for the Cool programming language, in which we'll implement everything in JavaScript and execute using Node, a command-line JavaScript engine based off of Chrome's built-in JavaScript execution engine for websites. So, to get started in on the semantic analyzer, the first thing we'll need to do is actually read in a Cool AST file, and then we need to be able to process this file and output finally a CL type file. So today, just to get started with the intricacies of JavaScript and some things that might trip you up if you haven't seen the language previously, we will do the process of reading in this AST file. So I'm going to get started in a text editor here with a basic JavaScript file once I can figure out where I want to save this. So let's save this in this types folder, and I'll just call this file main.js. So one useful thing here is probably to have Node's documentation up. We're using version 6 in this class currently, so let's get this up here. And so the first thing we're going to need to do is be able to read in a file. So I'm going to check out this file system API. We want to read a file, so I'm going to find that in here. We should have read file. Let's pull that up a while. Okay, so JavaScript program. I like to think about JavaScript more as a functional language in terms of the way things execute and the way I write my code. So you may see some similarities with the way that I've written Reason programs in class. And interestingly enough, some of the syntax for Reason was actually inspired by JavaScript to make it easier for web developers to switch over into a more strictly typed or very strictly typed language from JavaScript that's dynamically typed. And so as we discuss some advantages to strict typing and static typing are that we get better performance, and we also get a lot more guarantees at compile time about the safety of our code. In particular, we won't have certain typing errors occurring while the program is running. But like Reason, JavaScript will execute the code that we have in the order that it receives it. And so we can bind values to variables and call functions based off of those values. And so that's what I'm going to do here a while. So the first thing I'm going to do is make my life easier by importing this file system object here. So I can declare variables using this var keyword, and I'm going to bring in file system here. So the require says read in this other JavaScript file. Inside of Node, we can bring in all of the basic library code this way as well. And so once I have this with my var here, the var actually becomes very important because it has to do with our scoping and where this is available. If we drop this var off, this fs variable would actually be available everywhere in our program. Even if we defined it inside of another function, if we dropped off this var, fs would be available outside of that function. So generally speaking, it's good practice to use these var keyword everywhere we go. Now, we're going to talk a little bit more about the scoping of variables in JavaScript a little bit later on here. But I'm a bit old school, and there are newer things that give us more traditional scoping rules that we might be familiar with from other languages, whereas var is a little bit different. But because I'm old school, I use the older features like var, and that's what we'll see here later today. So I have this file system variable here. Let's go back and look at this assignment briefly. It's going to tell us that we need to take a single command line argument, so why don't we check for that? Now, Node programs have this object that we get automatically for us that's about the process that we're running, and it has a object member, argv, that is an array of the arguments passed in on the command line, and I can get the length of that and check to see, in this case, that we have 3 arguments. And the 3 arguments that we're going to have are our Node.js, followed by name of our file, followed by our Cool AST file. Now notice this operator that I'm using here is the not equals to, but here's one of the little tricks in JavaScript. If we only had a single equals sign there, we would get type conversions going on. So this means check for equality without converting types. Similarly, we can get the same thing with a triple equals, so no conversion of types here. You can run into some very interesting behavior if you only use a single equals sign. So something like this means that we can convert types when checking equality. Same thing for bang equals. So with these equality arguments, the basic rule of thumb is to use triple equals or bang equals equals unless you're really sure that you want type conversion, because you can run into various errors there with that. Anyways, we now have the, we know in here that we don't have the right arguments. So let's print something to standard out. We can do that with console.log. And I can just say something like usage Node.js main.js cl ast file. We terminate our statements with semicolons. JavaScript officially allows us not to do this, and it does some tricky things behind the scenes where if it gets an exception, it tries to go back and insert in semicolons until something works. Don't do that. Bad things happen again. If you watch one of Doug Crockford's videos, he'll spend a lot of time describing some of the weird error conditions that you can actually run into this. But for a starter, just make sure that you always have your semicolons here. And now we just want to probably quit the program. Process has a function exit that we can call with some error condition. So let's do that. And otherwise, let's just log what our file is. And so we have our AST file is going to be something like AST file. We can concatenate strings with plus in this language. Process.argv. We want the second element here. And we'll save this and quit. So let's just run this for funsies here. So I had Node up while I was playing around with these double and triple equals. So let's get out here, clean out of this. We're in types here, so I'm on a slightly different version of Node that requires me to just use Node. I believe on 6 we can use either Node or Node.js, but we're going to call this like such. It's going to yell at us because I'm missing a final Cool AST file. We'll come back to that later though, but let's just make up something funky here. So main.js foo.cl. There we go, we got our other output here. Looks like we're missing a space here, so let's go put that space back in and run this again. So we got our AST file foo.cl coming in. So the next step is really that we need to actually read in an official AST file and not just some fakeo command line argument here. So let's make ourselves a sample cool program. Here we go. We'll save this in types. We'll call it hello.cl. And we'll have class main. I'm going to remember how to write cool on the fly here. You can all laugh at me while I get the syntax slightly wrong here. So main type returns an object. and we'll say we want to use outstring, so we need to inherit IO, I believe is the syntax here, and we'll say hello world with a new line on the end there. Okay, let's see if this actually will run for us here. So cool hello.cl, hello world, awesome. So let's make our AST file for this. So I think we can just do cool parse hello.cl. We've now got our hello.ast, clast. We can see we've got this basic file here. So we've got a file that we can read in later. So let's go back to our JavaScript code here and actually read in the file instead of just printing out to the console. So we need to read in the file. Now, JavaScript uses asynchronous I/O, meaning that the I/O function will return back to us before we actually read in the whole file. And so the way this works in Node, so let's go back here, is we'll have this callback function. This is what we call once we actually read in this file. So we have our file system variable object, and we will call in read file on this. We need our AST file, so let's get that process argv2. We're going to say what kind of encoding this is. I believe UTF-8 in our case. And now we need to give a callback function. JavaScript allows for lambdas, anonymous functions. We can just make a function here on the fly. It needs to take in a couple things. Do we see here? Yep. So the callback is passed 2 arguments. We've got error and the data from the file. So error will let us know if something is going wrong here. So we just have a function. So this function gets called when the file data is returned. So once we have the file, we need to do a couple things with it. So let's check to see if we have an error. So if error, so if there's some value associated with error, we want to just say we couldn't open the file. Console.log could not open file. And exit again. So at this point, we know we have file. It's stored in data. So this file is just going to be read into us. If we remember the AST file, let's open it up here. Has interesting tidbits split up between lines for us here. So why don't we split our data into chunks based off of the lines? So let's do that right now. So I'm going to make a variable here, call it lines, and I will split it. So string we can split using the split function. I'm going to split on new lines. This is going to give me back an array of strings now, each one being one of the lines in our program. And so at this point, we are ready to read in all of the AST file. And so we just need to be able to read in a Cool AST file. So I'm going to go to the PA3 specification where we have all of our formats for the output. So at the top level, we have an AST or a Cool program. I'm just going to make a bunch of helper functions. So helper functions to read in CLAST formatted items. So I'm going to make functions for each of these. So function read program. To be able to read these in, each of these will need to have the lines array. And so we will be able to read in a program. Let's make each of these AST nodes into an object in JavaScript. So the main data type you can almost think of in JavaScript as an object, and they're quite easy to make. Rather than having classes associated with each object, we actually make the object on the fly and can add any fields or any methods that we want directly to this object. So I'm just going to make an empty object here. So var program equals, and objects are represented by curly braces in JavaScript. And so once we have this, eventually we're going to want to return our program here from this function. But first we want to build up the pieces of the program. So program is a list of classes. So let's make a field in the program, and we can just assign it here. And what we want to do is make our classes a list of AST classes. And so we can look and see how we might output a list, and we'll have to read that in. Turns out that lists of items show up several times, so we're actually going to make use of higher order functions here to save on some code. So I will eventually make a function here that we'll call readList, and we're going to need to pass in the lines to be able to read the list, but we also will need to say what function we're going to use to read each of these various items that we might have. So we'll have read class function that we do as well, and that should be good for a program. So let's make this read list function. So function read list, and we'll take in lines and the function that we'll want to call. So a list is outputting the number of elements, and then a new line, and then output each list element in turn. So let's make this into an array. Arrays have bracket notation in JavaScript, so var list equals, let's do, so we got an empty list now, we'll return that at the end. And so now what we need to do is we need to read the first item off of our array of lines. So we can do that with a, I believe it's called shift operation here. So we can get the number of items that we have using shift on an array. That will take off the very first element of the array, whereas pop will take off the very last element of the array. So we've taken off an element here now, and for that number of items we need to read in that many elements. So we can use a for loop here, and so it has very similar to what you might expect from, say, Java. So we're going to declare this with the var scope again. What the var means is that we actually have function scope. So there's really in old-fashioned JavaScript, there are only two scopes that you could have. You could have global scope, where it was visible everywhere in your program, or you could have function scope, which means inside of a function, after we define this here, this variable I is available everywhere, which is a little bit different from what you're used to. You're typically used to, in a programming language, this I is only available to us inside the for, but in JavaScript, this I is still available to us down here. Which is just a little bit weird, but something to be careful of, because you may end up overwriting variables that you didn't think that you could, or these variables might have values that you're not expecting. So just remember, var makes a variable have function scope. So available anywhere inside of this function then, once we define it, anywhere after our definition officially. So we have this for loop here that we're going to be working on. we want to add elements to our lists. I'm just going to use the push function, which adds an element to whatever array we're calling push on. And I need to read an item out of this list. How do I read one of those items? Well, I'm going to use whatever function I pass in that tells me how to read that element. So all I have to call is f on lines here. And so this is good enough for me to be able to return a list of anything. So let's read in a class now. So we'll make this function here for reading in a class. Notice I'm defining this function after I've already called it, but the way JavaScript works is it will execute through the program and will bind all of these functions to their names before we actually end up executing it based through this reading in all the files. So we'll read in the file here, which calls our initial read program, which by the time here knows the binding because we've already read in all the function definitions. So let's read in a class here. So we need some sort of class object to be populating. Class object.name equals, that's going to be an identifier. So why don't we write in an identifier? We'll need lines to pass to that to read it. And now we need to check whether or not this inherits or not. So why don't we shift a value off of the lines array, and if it equals no inherits, we might say that the class object.inherits equals false maybe. Types are not static, so I could then otherwise say that it's the name of the superclass that we get back here next, which we actually read in as an identifier. So I should actually use read ident lines here. And so this is either going to be false or string, which is also where the triple equals is going to come in handy later on for us. So we now have the inheritance here, and the final thing that we need is our features for this class. So class object.features equals, notice it's a list again, so I can use my read list lines read feature, and finally return this class object. Okay, so we need to be able to read in an identifier, and then we'll need to read in features. Let's do identifier first. So function read identifier. I think we just called it read ident. Looks like that. Lines. And okay, so var ident equals some empty object. There are neater ways to write this down that take up fewer lines, but we're being a little bit verbose to simplify the overall design here. So to read an identifier, we need to get a line number. So ident.line is going to be lines.shift. So we'll get the line number, and ident. What do we want to call this? Ident maybe will be the next thing that we shift off. And so we can just then return the identifier, if I spell it correctly. Okay, so we can read in identifiers now. We also need to be able to read in features, which we haven't done yet. So function read feature lines. I'll try to type this correctly again. Okay, so to read in a feature, we need to get its name. So feature object will be empty to begin with. Feature object dot name equals read. I don't actually like name for this. I prefer kind, I think, for the kind of feature that we have here. Lines dot shift. And now, depending on what kind we have, we read this in slightly differently. So let's use a switch statement here. To switch on the various object kinds that we might have. So we have a couple cases for this. We could have an attribute no init. We're going to need to break out of each of these cases then, so I'm going to put those in so I don't miss them later. Attribute init and case method. And we'll have also the default case where we're just going to break, but may want more checking here in the real world. So if we have an attribute no init, we're going to have a name and a type. So let's do those. So feature obj.name equals read ident lines and a let's spell feature correctly. Feature dot feature type read ident lines. Okay, so I've just read in name and a type into this if I have a no init. Otherwise, if I do have an initializer, I will need these same things again, but also the initializer, which is an expression. So let's read an expression like that. Now method is going to have a name, read ident, and a formals list, looks like. Feature obj.formals equals read list lines read feature. So we'll have to implement read feature, and then a type. So we've got some return type equals an identifier, so read ident line, and then our body, so feature obj.body equals read expression again lines. So let's fix this here to be lines as well. And once we've read in our various specific feature things, we'll just return this feature object. Okay, working through what we have now. Next we have to output a formal here. Or read in a formal, actually. So function read formal lines. Okay, so what do we have to do to read in a formal? So var formal obj equals empty object, get started again. And so it's got a name, it looks like. So read identifier. We need to pass in lines here. What else does a formal have? It has a type. So formal type equals read ident lines, and then return our formal object. Cool. We're getting yelled at here because I don't have a semicolon and used a comma up here. There we go. And we don't need a semicolon there. Okay, so we are now moving on to expressions. I'm only going to do a subset of this just because I want to keep this somewhat brief, but enough that we can see how this might work. So function read expression lines. Let's see, why is this yelling at me? It's saying I never use it. This may just be my text editor being goofy, and it's actually because I flubbed here. We're not actually reading features, we're reading formals. So when we read in the formals, we want to read in a list of formals. So finally here, we want to read our expressions. So we will have our expression object. It's empty. We'll return the expression object at some point here. And okay, so we need to output the line number of the expression and then a new line. So let's read that in here. So expression object.line equals lines.shift. Just pull off that line number there. And then we need to get out the name of the expression and then a new line. And then any of the parts. So we'll call this its kind again. And so now we have to specify, in particular for each expression type, the things that we're storing. So I'm going to do that with the switch again, and switch on the expression object kind, and we'll do a couple of these. So we may have an assign case here. So let's do this. Expression object dot var equals read ident lines. Expression object the right hand side equals read expression lines. So that's all we need to do for an assign. Next we might have a dynamic dispatch here, which is going to be the expression object gets, what does it get? It gets an E, which is an expression. So we'll read in an expression. It gets a method, which is an identifier. It gets a args list. So we'll read in lines of an expression list. So lines read expression. And there we go. So that's dynamic dispatch. Break there. Case static dispatch. So this is where we give the class name of the particular method that we want to call. So we will have our E as well. We'll also have the type, method, and args. So let's just copy this and update it. So it's going to be expression type here. Dispatch type, we'll call it here. And we are reading in an identifier. So the reason I'm not calling these type everywhere that this happens is when I do type checking, I'm going to be assigning a type to each of these expressions. And at that point, that feels more natural to me of what I would want the type field inside of these objects to actually store. So I'm storing these off to the side slightly here. It's up to you what your final design is. Doesn't particularly matter what you name these as long as you know what they are so that you can call them in the future. Let's also do a self dispatch here, which is a method and args. So we'll just pull this tidbit here. If we're looking at our hello cool example, that should be enough to get us most of the way there. We still need string constants, and we may also need math, hypothetically, for some of these things that we're doing. So something in the case of our math, we notice all of these various expressions have more or less the same form. So I might do something like case plus case, oh, I totally can spell. Case times case divide case LT, case LE, case EQ, and so all of these get two features or fields, whatever we want to call these. So expression object, looks like we've been calling these X and Y, so read expression lines, expression object Y equals read expression lines. Cool. We said that we need string constant to be able to do our hello world, so let's get one of those in here too. So case string, and we're going to have expression object, we'll call it the const, is just the string constant, so we're going to just shift that off of our array here. And finish this up with the remaining expression types. So we would have to do while block new is void, not, negate, integer, identifier, true, false, and also let in case. I'm going to skip over those for the time being because this is enough for us to get started, I believe. And so we have all of these various functions here going all the way up to our read program, which is what, if we back up several steps, we start out by saying we're going to read in our file that we pass in on the command line, split up that file into lines that we can actually process. And so what we're going to get back here is we want to get back our full program from the AST. Maybe I'll call this my AST equals read program lines. And because of the way that we wrote these, we'll make all of our calls through. So read program will read in a list of the classes. The classes read in all the way down to where we're getting into our expressions. So just for funsies, I'm just going to log this AST out to the console and see what happens here. So let's see how badly this actually went. I'm going to come over here. I'm in my types place here, so I can call node main.js on my AST file. So let's do that. We are running into issues here where we're saying read lines is not actually a thing. That's because it's read list, I believe. How many of you have been screaming at your computer about this? Read lines. Oh geez, we did that lots of places. So let's fix this. And try to run again. And what we'll see is that JavaScript tries to print this out as best it can to the screen here for us. So we can see we have an object with the curly braces that has a field classes that contains an array of single object here that has a name, it inherits something, and it has features. So eventually what we're going to want to do is be able to print this AST out. So if we look at what's going on here with our semantic analyzer, so let's go back to the semantic analysis page here. What we're going to do is we read in this cool AST file, and we need to go through this AST file, see if this is valid or not, and then emit this cool type file, which is a serialized cool abstract syntax tree. So we're going to print out the AST that we just read in again with our additional annotations, as well as some additional files that are described in this assignment. But at some point we need to be able to print out this abstract syntax tree. So let's go through and see if we can do that a little bit better here. And I'm going to use the toString method, which I believe JavaScript actually defines on all objects, similar to how Java defines this. And this is what the console.log actually calls to try to get a string back out to print to standard out. I could call this whatever I want and then just make sure that I call that function appropriately. So let's start with our program. Just like I can make fields in a program for the various classes that I have, I can also define a function that you can call on a program object. So program.toString is a function, doesn't take anything, and it's eventually going to return back to us some sort of string. In our case, we will need to take this list of classes and print it back out for us using the previous definition here from PA3. So PA3, let's click on that, go back and look and see how we're supposed to output this list. We'll probably want a common function for printing out lists. And so we could just return list to string. Now here, inside of this function, we want to make sure that we're returning back the string for the particular instance of this object that we have. And so we can use this to reference the context that's being called. So this refers to the actual object on which we called toString. And so we can get anything out of this object, for example, classes, to be able to access those values when we pass this to list to string. And we'll probably need a new line here. So let's define list to string here. So we've got some lists that we're passing in, and I'm going to start off with some variable string that's empty, and we'll build it up. So lists start with the number of elements in this, so we will add on to the string the length of this list, which is just a field in JavaScript. If the length is greater than 0, then we need to output all the items in here. And so I'm going to use some higher order functions to be able to do this. First, I need to output my new line here, and then I need to output all of the elements of this. So I'm going to do a map to take all the elements of this list and map them to their string output. So we're going to add on, from our list, we can call map on it. This is slightly different syntax from reason, but same idea for the way this is going to work. So I'm calling map on this array, and I'm going to pass in a function that takes in an element and tells me what to do with that particular element. So in our case, all we need to do is return that element's string. So return e.toString. And there we go. We just were able to map this list to, or well, in this case, array in JavaScript is our list type. All of the elements to their strings. So now we have an array of strings, and I can take an array and I can join the array with new lines to get back one long string that we can pass back and concatenate onto our string. And then we'll just return back our string. So in the case of classes, this means that we're going to call the toString of our class object rather than going through all of this here. Let's just define a basic toString method for our classes. So we'll have a function here, and we'll return something like class followed by its name, so this dot name. And now, just to be safe, we will console.log program ast.toString. Now, objects and typing in JavaScript is dynamic, so we have dynamic typing here. So all of these objects, we just have to be sure they have this toString method. It doesn't matter what kind of object it is. JavaScript doesn't really differentiate in that sense between objects. It uses what's known as duck typing. So if it walks like a duck and it quacks like a duck, it is a duck to JavaScript. And what that means is if it has this toString method or it has the right field like X, we don't care how it got there, we'll just read out its value. And so before I can quack any more jokes about duck typing, let's try this out. So I'm going to rerun this program here, and we see that we've gotten a little bit farther. So we got this class. Name, though, is not just a string, it's an identifier. So let's come back here and tidy up some more here. Where am I? So this dot name, let's call toString on this to be safe. And so a name is an identifier, that's how we read it in. So let's give identifier something here. So we will say ident.toString equals a function where we will return this dot ident. Let's run this again. Look at that. We got out what the class name was here. And so we've been able to see quite a bit here with the JavaScript programming language just by going through this basic example. So we saw how we can read in another library file, in this case the file system library, how we can use that to read a file, where we have a callback function that gets called once the file is read in, and we do our computation on the data of that file. We saw splitting up an array into multiple pieces, or excuse me, splitting up a string into an array of multiple pieces, and then implementing several functions in JavaScript, starting with read program, where we pass in our lines array. And once we are reading in our program, we then saw an example of making our own higher order function where we can read in lists using any sort of function that reads in an object from this lines array. And so we have this generic read list that we call in this case on read class, and we work our way through this. We also saw printing out to string, so we defined methods that we assigned into objects in JavaScript that called functions, used member variables of the object from the current context, which is assigned via this, or is denoted via this is probably a better way to say this. And we saw real-world working example of this code working in Node. Now, Node has one nice feature that I haven't pointed out yet, and this is its ability to interface with Chrome's debugger. Getting started with JavaScript, we have these two flags that we can pass into Node. So if I do that here, and then pass in my file here, hello.coolast, it's going to say to start debugging, we can open the following URL in Chrome. So we're going to do that. Let's get Chrome up. Wonder what I had last up in Chrome. Oh, it looks like it crashed a lot last time, so we're good here. So I'm going to go into my developer tools here. Looks like I was teaching a class last time here, so things are super big. We see that we're stopped right at the beginning of this program in our Chrome developer tools. Now, I may want to do something like set a breakpoint right when we get inside this function for reading a file. And so I'll go ahead and play ahead to this. I can see that error is null. We get a command line here where I can type in anything that I want while the program's running and get things out here. I can hover over variables to see what their values are. I can step through. I'm going to, let's take a look at data. Data we can see is just a string. We can call this split and now look at lines and see that we have this array of all of the lines from our program. And I could jump into this function here. And so I'm going to start making up this program object. So program has nothing in it beyond this proto field. JavaScript has what's known as prototype-based inheritance, where all objects have some prototype, some mold of what they came from, and this is sort of how we can have a chain of inheritance you can think of in JavaScript. If you're curious, there's lots of reading online about prototype-based inheritance, but for our actual uses of JavaScript here, which are fairly limited, not the biggest thing to worry about. But let's read our list here. So we can see we still have this lines array. These objects are passed through with objects like arrays and objects being references. So anything we do to this lines array here will have effects anywhere else we have a reference to it. And we've got this function read class that we've got passed in here as well. So we're going to start by making an empty array. We'll get the number of items. So now we'll see lines no longer has the same values here as we did before. And we'll go through this for loop here, and we're going to call f on lines. So read class, we see that we got this newly updated lines array here. And we'll read in an identifier. We will see that it actually does inherit something, so we're going to read in our identifier so that it inherits from IO, and we'll keep going. I'm going to jump out of this function, jump back up here. So we're reading the program, and now we're going to define the toString method on the program object. And now we can return our program, which has class, single class. We can look inside here. It's got an object here with the classes, so it's got its features. We've got this method here. It's got no formals. It's got a body of a self-dispatch where we're passing in a single argument, which is this hello world. It's a string kind, and it's on line 3. And so now we could console log toString, and we are jumping too far down in, so let's go back to toString here. And so we're going to call this list toString. I can go through here. If I want, I can set a breakpoint inside of my map so that I can get inside and see how this works. So the first element is our first class here that we'll go in and get a string of. We'll get that back. Our return value we can see was class main there. And we're going to join those all together with new lines, and we can see our string here is one class main now. So this can be particularly helpful for finding flaws in programs and seeing where and why we get runtime errors. And once we're done, we just have to close out these developer tools, and we're back to our main console here. So that's a brief introduction to JavaScript. Obviously, if you have any further questions, feel free to ask on the class forum, and I'd be happy, or the TAs would be happy to help you out.